Namaste and a very good afternoon to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about a very interesting statistical test, which is called as Levene's test. Even before I proceed to demonstrate what exactly is Levene's test, may I request you to subscribe to my channel, also like and share my videos. To begin with, let me ask a simple question as to what exactly is Levene's test. There are many statistical procedures which require that there is equal variances in the samples. Question is, how do we check whether their variances are homogeneous? That is, whether there is equality of variances or not. The answer to this question is Levene's test. Levene's test is used to check whether the groups have equal variances or not. In Levene's test, the null hypothesis is that the groups have equal variances, and the alternative is that the groups have unequal variances. After running the Levene's test, we get the p-value. If the p-value is less than 0.05, we conclude that the groups have unequal variances. On the other hand, if the p-value is greater than 0.05, we can go ahead and conclude that the groups have equal variances. Now, there's a big advantage of using Levene's test, and that big advantage is that Levene's test is very robust to the violation of normality. Since Levene's test is very robust to the violation of normality, we do not explicitly check whether the distribution follows normality or not. Secondly, we can also check whether there is equality of the variances or not using graphical measures like scatter plot and box plot. With this background about Levene's test, let's now look at the data set that we will be working on. This data set is called as the credit risk data. There are two variables in this data set. One is the credit rating of a customer. Second one is age of the customer. If you can see here, there are two categories. One is bad customers and good customers. We have classified the customers into two groups depending upon whether they have defaulted upon the payment of loan or not. If a customer has defaulted upon the payment of the loan, historically, he is called as a bad customer. On the other hand, if the customer has paid the loan all along in a timely way, we will call him as a good customer. So these are the two categories of customers that we have, bad and good. So I will be using this particular variable as the categorical variable, and we will be checking whether the variance in the age is the same for these two groups of customers. To check whether the variances for the groups is the same or not, let me use Statcraft. As you can see here, I've already loaded the data set from spreadsheet into a tool which is called as Statcraft P. This helps me do hypothesis testing as well as advanced machine learning algorithms. These are the two variables, credit rating and age. As part of the exploratory data analysis, to check for the equality of variances, we can use either the scatter plot or the box plot. For this video, I will be using box plot. Let me click on the analysis tab. There are different measures here. I will scroll down. Here, you can see an option which is called as graphics. Let me click on the graphics option. Scroll down. Here, you see an item which is called as box plot. This opens up a new dialog box which is called as the box plot. Let me minimize the size of the dialog box. Initially, the box plot will appear like this. In the canvas on the left-hand side, you can see the two variables, namely credit rating and age. And to the right side, you have the variable section. Let me choose a grouped box plot. This gives me a different setting. I have to specify the X variable and the Y variable. In the X variable, I will select credit rating, and in the Y variable, I will use the variable age. Once you have selected the variables in the X and the Y list, the next thing to do is to go ahead and click on the OK button. This will generate a box plot. Statcraft takes a couple of seconds to run the analysis. This is the output window. You can see here in the output window, Statcraft displays the Python code which it is using at the backend to create the box plot. Let me scroll down. You can see here, this is how the box plot appears in Statcraft. There are two groups. The first group is bad credit risk, and the second group is the good credit risk. The solid line in the center of the box is the average. You can see here, the average age of a bad credit risk is less than 30, and the average age of a good credit risk is 35 years, approximately 35 years. So good credit risks are 5 years older as compared to bad credit risks. But more than comparing the average here, we can look at the size of the whiskers. The T-shaped line here represents the whiskers. When you look at the size of the box firstly, and also the size of the whiskers, and compare it with the second box plot, clearly the size of the whiskers for the second box plot is longer. What does this indicate? Because the size of the whiskers for the second group is larger, we can go ahead and conclude that there is more dispersion, there is more variance for the second group as compared to the first group. Though graphically, we can see that there is a difference in variance. Question is, statistically, is there any evidence for us to conclude that the homogeneity of variance criteria is violated? To check whether there is homogeneity of variance or not, statistically, we will now run the Levene's test. To run the Levene's test, you can again click on the Analysis tab. This opens up all the options in the menu. I'll click on Compare Groups. Here we have what is called as Levene's test. Let me go ahead and click on Levene's test. Let me quickly refresh the options here. You can see the two variables. The first is a categorical variable, credit rating, and the second one is a scale variable, age. Under the variable section, you can choose a scale variable. And when it comes to category, you can choose credit rating. By default, the option under the center value is median. Once we have made these selections, you can go ahead and hit the OK button. Again, it takes a couple of moments to run the analysis. Let me quickly show you the output of Levene's test. Here we have Levene's test for equal variances, and this is the Python code which Statcraft has run at the backend to create the output of Levene's test. You can see here Levene's test for equal variances. There are two columns. The first is the Levene statistic value, which is 37.15. We also have the p-value. The p-value that is calculated is 1.3 into e power minus 9, which is a very, very small number. We will approximate it to 0.00. Now, how do we interpret the p-value? The p-value has to be compared with another value, which is called as level of significance. The p-value that we have obtained for the Levene's test has to be compared with 0.05. If this value is less than 0.05, we can go ahead and reject the null hypothesis. On the other hand, if the p-value is greater than 0.05, we fail to reject the null hypothesis. Clearly, what we observe here is a p-value of less than 0.05. Since the p-value is less than 0.05, we reject our null hypothesis and conclude that the groups have unequal variances. So this is a very straightforward analysis. Because the p-value is smaller than 0.05, we will conclude that the groups have unequal variances. Let me go back to the Levene's test. Analysis tab, compare groups, and here let me select Levene's test. Remember, under the option for center value, we had chosen median. Let me now choose a different option. I will be now selecting the option mean. Let me hit the OK button. Looks like our output is ready. Let me scroll down. This is the earlier analysis that we had done. Now you can see Levene's test for equal variances. Under the option, you can see the argument that we have used is center equals mean. The Levene's test value is 35.10. What is the p-value? It is 3.6 e power minus 9. Again, this is a very, very tiny value, very close to 0. Here again, we can say that the p-value is less than 0.05. Since the p-value is very low, it is less than 0.05, we can go ahead and reject the null hypothesis and conclude that the groups have unequal variances. So this is how we can use Levene's test as a prerequisite before running some of the other analysis. We use Levene's test primarily to test for the homogeneity of variance assumption for two important statistical tests. The first test is independent samples t-test, and the second one is one-way analysis of variance. For both of these statistical tests, there is an assumption saying that the groups have equal variances. We have to perform the Levene's test first and then perform Anova. So with this, I have come to the end of today's video. I thank you very much for watching this video. I request you to subscribe to my channel, also like and share my videos. Thank you very much. Once again, have a great day ahead.